Hello everyone, welcome to my channel. Today I want to show you an counterexample of the Riesz Representation Theorem. But first, I want you to relax because I'm not going to prove that it is not correct. Instead, I want you to focus on the quantifier here, which is finite. Now, let us suppose that V is an infinite space. Does the theorem still hold? No. The answer is no, because I can give you a counterexample. So now look, let V be all the continuous functions with real coefficients from -1 to 1. We define the inner product on the space Fg as the integration of -1 to 1 of fx gx. Let us also define that phi of f equals f of 0. I'm now going to show you that we can never ever find a g such that this guy here holds. And I'm going to show you by contradiction. Let us assume that such a g of x exists. Now, phi of f equals the inner product of f and g, which equals the integration of fx gx from -1 to 1. So notice here that g of x stays the same as fx varies. Now pay attention to this f prime, which equals x squared times g of x. This g of x here is just the g of x that we assumed earlier. Also notice that x squared is a continuous function, and g of x is also continuous, so f prime of x here is also continuous, which means that it belongs to V. Great. Now let us calculate phi of f prime, which equals the integration of f prime gx times gx. And by our definition, this guy equals f prime of 0. What is f prime 0? Well, since f prime 0 equals this guy here, so we can calculate that this guy here equals 0. Okay, now here's the trick. The trick is x squared times g squared must be a number that is larger or equal to 0. But here we want this integral to be 0, which implies that x times g of x can only be 0 for x from -1 to 1, which again implies that g of x equals 0 for x that belongs to this interval. Can you get it? Okay. Now, we want to recalculate phi of f. Since we know that g of x equals 0 anywhere except at 0, so the integral here should be f0 g0, which by our definition here equals f of 0. G of x holds for any f that belongs to V. So we can always find an f of 0 that is not equal 0. So in this case, g of 0 has to be 1. Have you found the contradiction? Let me tell you. Since g of x is an element of V, which is all the continuous functions from -1 to 1. But now we have found that g of t is 0 anywhere except at 0, but it equals 1 at 0, which, if you draw a picture here, you will notice that it is not continuous, which is a contradiction.